right, shall we? Welcome back, Jon.
Thank you. I have returned to Boston just for this one thing.
You knew we were behind, and you thought to yourself, "We've got to get there in person. We've got to do it. We've got to come, and we've got to just get caught up."
Yep, I've got to wrestle Ben until we've done all of it.
I was obstinate. I was petulant. I did not want to do it, but Jon put me in a headlock.
Yep.
Gave me full Nelson.
I found out
in fact, that's what's happening right now.
Yeah, I found out where he lived, and I went there and dragged him out of his place and said, "We got to record this."
Secretly, he's a Brazilian jiu-jitsu black belt or whatever the equivalent is.
Not so secretly, very publicly.
Now, this is the announcement, is that I'm currently being pinned with my life in threat unless I continue and consent to fully of my own volition, continue on talking about the newest quote unquote Rust releases as of last year. We're not that far behind. We've got 3 today. We're gonna.
That's true. Although I would just say you've been voluntold.
I've been voluntold that we're getting caught up right now.
Yeah, and the place we're going to start is Rust 185, which was, as we all know, released on February 20th of 2025, which is totally this year.
Totally this year. And importantly, this version also introduced the edition, the 2024 edition, which is totally this year. So, but we're not talking about that today. We're going to have a bonus episode talking about the edition because there's lots to go through.
Have we had a bonus episode before?
I don't know. It's the first one for everything. It's a new year, new us, or old year, old us.
Yes, exactly.
And so let's just talk about what happened beside the edition in 1.85, because there's always new changes.
Yeah, and I think it's something that it also gets kind of missed in the discussion.
Yeah.
It's the 2024 edition. That's the big thing.
We've got to give these features their due.
Yes.
It's their time to shine.
Yes, exactly.
Much delayed time to shine. So we've got async closures are the first bullet point here. And Jon, you're an async kind of guy.
I'm an async kind of guy.
Rust stuff. So why don't you talk about what an async closure is and why do we need async, the async keyword applied to closures?
Yeah. So, you've always been able to write closures that are kind of async, right? So you can write closures with the double pipe and then write async after the double pipe. And what that is a closure that returns a future. The difference though is that we now have asynchronous closures. So these are things where the async keyword goes before the double pipe. The big distinction between these is that they end up implementing different traits. They also end up behaving differently in terms of what they capture from their environment. So if you have an asynchronous closure, then you can have the future that you return borrow from the environment that's captured by the closure. Well, what I mean by this is, like, if you have imagine you have a closure that is move, and then inside of that you have an asynchronous function that is not move, then that would mean that the value is moved into the closure, but is then borrowed in a shared way by the async block, so by the future. So these two end up having different sort of capture rules, or in the sense of one gets to move and the other does not, or they both move, or the other moves, or neither moves. But with this new setup where you have an asynchronous closure, if you choose to move into the closure, what you're actually doing is creating an async FN that captures all of it at once. Or if you have it be an async, just async double brackets or double, pipe without a move, the asynchronous function borrows it gets to borrow the whole, like, captured set of variables and values. This ends up mattering for, I'd say, 2 reasons. The first is it's slightly nicer syntactic sugar. So if you now write, if you want to do an async move, then instead of previously you would have to write move double pipes, async move open curly brackets, you would have to write move twice. Now you don't have to do that. You can just write async move and then the thing. But the other thing that is a big difference here, and arguably the bigger thing, is that you now have the async FN traits. The async FN traits are like the FN traits, like the function traits, but the async FN traits represent asynchronous functions. And you could write something that looked kind of like this before. So you can say that I'm generic over an F, where F implements FN, and where the fn returns a type that implements future, right? So usually what this would look like is you would have a function that takes two generic type parameters, f and fut, and it would take an argument that is of type f, where f colon, fn parentheses returns fut, and then on a new line, a new separate where condition, fut colon future, and then some output type. Now you can instead just write, for the same kind of setup, you only need the f generic, and you can say where f colon async fn. The reason this matters is because when you have the where clauses split across two generic types, you cannot have lifetime dependencies between them. So you can't say that the function is provided with an argument that has lifetime tick A, and the future it returns has an output, it has an output that is tied to that lifetime. You wouldn't have a way to express it, because if you wrote tick A in the where f line, then that tick A doesn't exist anymore. You're in the where fut line. There would be different bounds, and so you can't connect them together. Whereas now, when you just have where f colon async fn, the lifetime of the arguments list and the lifetime of the return type list is now in the same bound, and so you get to put dependencies between them. These are sort of higher ranked lifetime bounds, if you will. And so this is something that's now possible with async fn that was not. And crucially, asynchronous closures, so async double pipe, implements the async fn traits, whereas non-async closures do not. There's also a bunch more discussion here if you look at both the RFC that introduced these and the stabilization report. They both talk a lot more about the sort of nitty-gritty, both of why this was hard, but also, the kinds of things you might use it for. But just in general, know that now library authors have a better way to express input functions that need to be asynchronous. Like those can be now better generic in a way, right? Because they can allow the return of the asynchronous function that's passed in to be tied to the lifetime of any of the inputs. But also, just as an author writing code that interfaces with these, you can now write async closures, and you don't have to worry about the sort of weird ordering of the keywords for those. The next thing we have in 185 is hiding trait implementations from diagnostics. And I don't know if you know, Ben, but why would you ever want to hide things from the user?
Well, I think so. This is not the first sort of diagnostic or sort of like feature that allows you to hook into the diagnostic machinery, where by that we mean the compiler error reporting machinery. And so I believe it was the year before this, there was the new ability to use these diagnostic namespaced attributes in certain places to customize the output of the compiler whenever there's an error in certain ways.
Yeah, I think it was specifically for like recommending particular traits with like customize the wording of the recommendation.
And I think this is the opposite, where it's saying, hey, if you want the compiler to not recommend certain traits, and so if you're a library author and you're doing kind of complicated trait stuff and you're getting polar error messages in practice, if you're using it and saying, this is kind of a bad experience for my users, you could potentially use this trait to tailor both the previous one saying what to recommend and this one to say what not to recommend, to make it easier for users to understand how you intend for them to use the library.
And I think the example they give here is good too, right? Where you have two traits foo and bar, and you have a blanket implementation of bar for anything that implements foo. And so the compiler doesn't necessarily know that blanket implementation is sort of intended to be used in that way. So it might recommend, when it finds in user code that someone, like you needed to have implemented bar, then the compiler will just tell you, well, this type doesn't implement bar, maybe you should implement it. But implementing bar is never what you're intended to do. You're supposed to implement foo, and then the blanket implementation gives you bar. And so this would be a way to sort of say, well, just never recommend that the user implement bar.
Up next is FromIterator and Extend for tuples. And so,
I'm pretty excited about this one.
Yeah. So this one, what you do is, if you're aware of collect in Rust, the collect method on iterators, where it's sort of very generic and allows you to turn an iterator into any collection that has the FromIterator trait on it. Now we have tuples up to length 12, like arbitrary types up to length 12, tuples that you can just collect into. And the feature here, the example here even goes so far as kind of like show you, hey, we've got a tuple and like every individual field, a three tuple, where every individual field is a different collection that itself is like part of an original collection. And so we have, like you can have a list and then you can have a tuple of the squares, the cubes, and then the tesseracts, right? For all the underlying lists. And one is a vec, one's a vec-tq, one's a linked list for no good reason, just to kind of show off the feature. And so if you're really big into using collect and getting a tuple out of it, that's pretty cool.
Yeah, I mean, I think, in the early days of Rust, we had the unzip function on iterators, right? So you could have an iterator, where the items of the iterator were a two tuple, like type A and type B, for example. And you could call dot unzip, and it would be a way to collect all the A's in one direction, all the B's in a different direction. And that, I think there's also, is it dot partition or something, which is a similar thing. And that's really useful, but it only worked for two tuples. And so the nice thing here is now you can collect into, like, if you have tuples of length n in your iterator, you can collect into n different collections the items for each of the n different tuple things.
For n less than 12.
Yeah, why 12?
I'm not sure who decided. I mean, so, in the absence of, variadic generics, you can't implement it for all possible tuple sizes. So so someone just had to, at some point in the history of Rust, pick a number, and they were like, 12 sounds good enough. No one's ever going to have a tuple of more than 12 elements where they need to do wacky things.
No.
Right?
No.
Nah, that can never happen.
I mean,
so
three tuples are enough for anyone, right?
Maybe even two tuples, right?
Maybe. I mean, who needs tuples?
We can go full Golang.
Yeah, that's true. The next one is an interesting one, which is an update to stud and homedir. This is a function that used to be deprecated. Like, it's been deprecated for, I think, 7 or 8 years.
2019?
2018. It was deprecated. And now they've decided to fix it and undeprecate it. Why this weird cycle? Like, why go through the process?
Well, so Rust Standard Library has kind of this stability story where you, once a function is added, you can't ever remove it, right? But there's a question of, well, how can the behavior change? And so, in certain ways, with regard to like I/O, for example, right? You could always imagine, something on the platform has changed, and now this function maybe returns an error or does something differently. As long as it's within the original contract of the function, you can change behavior to some degree. And that's the usual sort of line. And then at some point in 2018, 2019, the idea was, hey, on Windows, we're referring to this environment variable, which I suppose is not the right way of doing it. Someone at some point was like, hey, like in certain configurations, this just does not work. And so the function was itself deprecated, and I suppose it was marked as such in documentation. And then normally in Rust, whenever a function is deprecated in this way with the idea of replacing it in some better version, you would just leave the old version around and then add a new version that was named differently and not deprecated. And I guess they were kind of like, we'll just reuse the old one when it came time to finally fixing it, quote unquote, right?
Yeah, I think part of I dug into the original discussion here a little bit, and my understanding at least is that the original, the sort of the version that was deprecated was just wrong on Windows. Like, it was just useless.
It never worked at all?
It used the home environment variable if it was set. Otherwise, it would fall back to user profile, which is the thing you're supposed to use on Windows.
Okay.
But you should just never look at the home variable in Windows. Like, that environment variable just doesn't have any semantic meaning. But the thinking was, well, it does the wrong thing if home is set, because home is just an irrelevant variable on Windows. But we can't remove home from the list because that would be a breaking change in case someone were actually relying on that. But we don't think anyone is because it makes no sense. Just in case we don't want to change the behavior.
So, yeah, and then the sort of unprecedented thing here is that the behavior was fixed and the function was undeprecated, I guess, which I'm not aware of any previous instance of this.
Yeah.
So
I guess, part of this is maybe we don't think anyone relied on the old behavior, and we have also deprecated this function for 8 years now. Let's just fix the broken behavior on Windows, which we don't think anyone relied on, and assume that anyone who did rely on it has seen the deprecation notice in the past 8 years.
It's still rather bold, though.
It is bold. I agree.
You often see much more conservative behavior from the library side here.
That's true.
So,
and then we have the list of stabilized APIs. There's nothing here that like really stuck out to me as super interesting.
I think there's a lot of convenient stuff because like I see float midpoint and integer midpoint and non-zero U, etc. midpoint. The idea being, hey, like if you're what's cool about this is that it avoids footguns with overflow. So they're guaranteed to never overflow. So midpoint is I have 2 integers or 2 floats or whatever. I want to find the thing in between, and the natural thing to do is you add them and then divide. And the addition could overflow conceivably, and so you have sort of error handling involved, or you'd have to extend the types to a larger size first, then do the addition, and then recast to the lower size and divide, etc. And this just does all for you. And so I mean, like we're still finding new convenience things to add. So
I mean, we've touched on this before, right? That Rust tries to be very deep in the things that it covers.
Yeah.
Actually, there is one here that I've come to think of it, I've actually made use of, which is Waker no-op. So when you have a manual implementation of the future trait, or really any implementation of the future trait, there's an argument to that method called context. And one of the main things on context is the waker. The waker is a sort of handle to a thing that someone will eventually call wake on to indicate that this future can continue. So imagine the future returns pending because it's not ready yet. Then the expectation is that someone calls wake on the waker that was provided as an argument to that future. And then poll will eventually be called again and the future gets to make progress. Normally, in order to implement a waker, you need to either write unsafe code. You need to like manually write a vtable, or you need to use an arc waker. So there's a trait that you can use that is not unsafe, but that requires an arc. And now there's also waker no-op, which is if you have a future that doesn't care if it gets woken up again, you can, or if you're trying to like run a future and you know it will complete the first time you run it, and you need to generate a waker to give it that context argument, you can now use waker no-op, rather than have to like futz around with unsafe or with an arc.
I also want to call out this new function pointer in the pointer module. It's called fn adder eq, so fn underscore addr underscore eq, and it's kind of just the same thing as equality, as the equality operator, the equals operator, but when each side is a function pointer, and it makes it explicit that you are comparing the address of a function pointer, which is kind of curious, right? Because function pointers are themselves zero-sized. Right. So you'd think that, like, I'm not sure the details, but like zero size things I would expect have like very few guarantees about what the actual address they will give you if you ask for like, hey, where is this stored? And even here in the doc it says, hey, there are very few guarantees about how functions are compiled, and they have no intrinsic identity. In particular, it may return true or false unexpectedly.
Yep.
The only kind of guarantee is that if the pointers do compare equal, then calling F and calling G, either side, is equivalent, right?
Mm-hmm.
So I imagine someone's using this, but if you are, it's kind of like a nice convenience. So rather than using equals, make it obvious that you are comparing address equality as opposed to any other.
Yeah, exactly. Because I think that would be the worry, right? That if the two arguments you pass in here also happen to implement partial eq, then if you just did equal, then it would use the partial eq implementation for them rather than comparing whether their address was equal. And that might return a different result.
Maybe? I think it would be difficult to do that because the function pointer, so this fn adder eq function is bounded on two types that both types implement this fn pointer trait, which is a marker trait that I think only the compiler can implement. And so I think it would be hard to do that, but it does make it obvious that you are comparing for address equality, which is not normally how Rust works. And so I know in other languages like in Python, right? Or I'm not even sure, right? I know in some languages, if you use, maybe it's a JavaScript thing, maybe there's equals versus equals, right? And there's like some, distinction there between like deep equality and shallow equality. Rust doesn't usually have that. And so I think it's just a matter of making it obvious what we're actually comparing here.
I think that's all I had for stabilized APIs. I did have, one kind of interesting thing from the detailed release notes. So the one I have is in core, there's a module called FFI, and in the FFI module, there are a bunch of types that come out of the sort of C ABI world. One of this is C char.
I say care.
That one. And the rules for whether, like, what type that actually is depends on the platform. On almost every platform and almost every target, the character type is assumed to be signed. So it's an I8, even though many people assume that it's a U8. It's actually an I8. But on Windows and on Apple devices, it is a U8. And previously, Rust had this like giant conditional setup for like this platform and these architectures, this platform, these architectures, this. And they've just simplified it down to if it's Apple or Windows, then it's U8. Anything else is I8.
It'd be hard to imagine. I mean, obviously, if it's an alias for U8 or I8, you could do math on it. And I know people, possibly do. If you're like, oh, I'm going to be clever, I'm going to lowercase my ASCII values by just like, masking a single bit, which you can do. And that's the whole point of the ASCII being defined the way that it is, but I mean, I don't know. It seems like it's probably not really a big deal.
Yeah, but I think
signed or not.
I thought the sort of process they went through here, or the logic they went through here for this change is kind of interesting. So it used to be that they would be like, for this platform on these architectures, we know it's I8. For this platform and these architectures, we know it's I8. And sort of enumerate all the places where they knew it was I8 and enumerate all the places they knew it was U8. Now they've instead switched to everything is I8 except Windows and Darwin. And so this means that if a new platform comes out, we're just going to assume that it's I8 there. Rather than previously, they would have to manually update that table to say what that new platform was. And the rationale they gave for why this is okay is because this is what Clang does.
I guess, yeah, if there's...
So like, if Clang if this is the rule in Clang, then...
I mean, there are like, you could have crane lift exists as a thing, and so in theory you could have other backends, and so, but they probably want to not deal with signed chars.
I think it's that, plus they don't want to deal with manually updating this table anytime anyone wants
It was kind of a heinous looking table in that.
Yeah.
So...
I'll link it in the show notes if anyone's curious.
My last kind of points are, new const stable APIs. And so just like interesting things like size of val, a line of val, you'd think, that would.
I'm surprised those aren't const previously. Oh, cause it's the val.
You'd think that size of would be like the first thing to get constified, but size of val was not. Also, many float operations now becoming constified. I think in the previous year, there were lots of,
I think
the ability to use floats in const context at all was brand new.
Yeah, I think we talked about this in the previous episode of like the difficulty in doing so, because now the const output, the const results might not match the runtime results for floats.
Yeah, and things like mem swap and pointer swap also now working in const context, implying kind of like, weird things in Miri. Like dynamic memory, abstraction, or kind of, which is always had, but like, making it more powerful. So.
And then 85 also had a point release. There was a 185.1. The main thing was it fixed these, this notion of combined doc tests. So in order to speed up, Rust compilation for when you have many doc tests, previously they would just be compiled as like separate binaries. It would actually take quite long if you have many doc tests. And in 185, or I think as part of the 2024 edition, which we're not talking about right now, but, Rust will now build all the doc tests as one binary that can then run different doc tests depending on the argument. So it builds a lot faster, but there was a bug in that, broke some of these doc tests, and they had to fix that with 85.1.
All right, and that's it for 85. Shall we move along?
We will move right along to 186. released April 3rd, which is exactly as much later as it should be.
Mm-hmm. Unlike us, Rust is usually on time.
I know. Have we ever strayed from the release schedule? Not us. We've strayed a lot, but like the Rust project?
I don't, and maybe it happened like once, but it's pretty reliable.
Yeah, I mean, this is how we ended up with Rust 169 on 14, right?
Yeah, I think that was definitely planned from the outset. Yeah. So definitely between 1.0 and 1.69, there was no deviation because they would have known.
Yeah, exactly.
They forecasted it. So the first item in 86, trait upcasting, very large feature. Do you want to take this one?
Yeah, I can give it a shot. So the thinking here is that if you have a trait that has a super trait, so the trait definition as like, trait foo : bar, curly brackets, then foo is a subtrait or bar, or in other words, bar is a super trait of foo. And the idea of a super trait is that in order to implement the subtraits, in this case foo, you must implement the super trait bar. And in general, what this also means is that any foo is a bar, but not any bar is a foo. So foo has like additional methods that you might need to implement on it, that are not in the super trait. And what this change allows you to do is that if you have a reference to foo, so the subtrait, not the super trait, you can get a reference to the super trait.
It's not just a reference if you have a trait object.
Yeah, it's specifically for DIN-compatible trait objects, where so when I say reference to, like, the only way to have a reference to a trait is really with a trait object, right? So it would be a reference DIN.
But you could also have a box or any other trait object, right?
Yes. Yeah. I mean, I remember this is like old school Rust, right? But, it used to be that the DIN keyword was optional. So you could have
didn't exist.
Yeah, you could have a reference to a trait, and it would be the equivalent to what we now think of as a trait object. Just the DIN keyword was just optional. I think this was like 2015 edition, maybe?
Yeah, that was the edition.
But anyway, so now, when you have a trait object of any kind, to a subtrait, you can now get a trait object to the super trait. And previously this was pretty annoying, required you to write a bunch of unsafe code. And now this kind of upcasting, so casting up to the super trait, is directly supported by the compiler. It is not even unsafe because it doesn't need to be. And the thinking here on the sort of, how does this work in dispatch is that the V table for the subtrait for foo must necessarily have all the entries for bar because every foo is a bar. And so I don't know whether how they actually implemented this behind the scenes, but it does mean that if you have the V table for a foo, you should be able to construct the V table for a bar implementation. And the pointer to the actual data is the same. And so you can, if you have the sort of the fat pointer, the wide pointer to the subtrait, you should be able to construct a valid fat pointer to the super trait. And that is what's now been implemented.
Yeah, I think there are some restrictions with, like, it's not completely a free form with, the ability to, I think there's like, I'm not sure, like, again, the reality of needing to compile this to some kind of V table, limits, I think in some cases, what you can do with, like, the number of things you could, like, potentially upcast to. You can't, like, if you have, like, multiple super traits, you can't, like, upcast to, like, a different, like, set of them or something.
I don't know. I think you can, this should be fine to recurse, but I don't think it recurses for you. So if you have, like, a foo is a subtrait of bar, bar is a subtrait of baz, then I think you need to do 2 upcasts, but I'm not sure. Well, one of the most sort of, common use cases of upcasting in general, but certainly for why people have wanted this feature is for the any trait. So it's pretty attractive to make the any trait be a super trait of your trait because it gives access to the downcast method on any. So the any trait I think we've talked about in the past, but its primary sort of mechanism is that it sort of stores the type identifier of a type that is behind a trait. and it allows you to downcast a thing that is a trait object, so a din any, into a specific type T, or rather an option of a specific type T. And it does this by comparing the sort of it's not stored is kind of a lie, but let's say stored, like the stored type identifier for the implementation of the trait against the one that's in the trait object. And if the two are the same, then it knows that this din any is actually a T. And so you asked me to give you a T, so I'm willing to downcast this to a T. So the other direction than an upcast. And in fact, downcast it not just to a trait object, but to a concrete type. And so now, because you have this upcasting as well, you can now upcast to any and then downcast to a concrete type, assuming any is a super trait in the sort of chain that you have.
Mm-hmm. Very cool. All right. So, next one, HashMaps and slices now support indexing multiple elements mutably, which I think is really interesting. And so just to, again, reiterate, in Rust, the whole point is that you have aliasing XOR mutability, right? And so normally if you have an array or a slice or whatever, you can have one mutable pointer to somewhere in the array or multiple shared ones to multiple places in the array, but you can't have multiple mutable pointers to different items of the same array. And so in the past, there's things like the split mute method on vectors, which will let you kind of, take one vector and cut it in half, and now you get two separate ones that allow you to individually, out of their different objects, individually take mutable references to each individual one. This one is a slightly less, I guess, I'm not sure if it's, lightweight. I guess I'm not really sure how to describe it.
No, it's a little more dynamic, maybe.
I guess,
right?
yeah.
So something like split mute, you give it an index and it just does that.
Yeah.
It knows that it can produce two valid slices that are mutable
on each side of your index.
Yeah.
And so in this case, if you use this new get disjoint mute method, you can get past two indices and then it does a check that the indices are in fact disjoint, didn't pass in the same number twice. Right. And then it lets you, get multiple mutable elements to the same array. Which is very cool.
You can even give ranges as the keys here. So if you have a slice, for example, you can say, I want to get, 0 to 2, and then I want to get 5 to 7. And I got to give mutable pointers to each of those sub-slices of the array.
And you'll get slices back from that. Yeah. And
right.
Again, requires some runtime.
Yeah. So I think this is the big difference, right? Compared to something like, split mute at, for example, is that now you can give in runtime dependent parameters. But when you do, that does mean that there has to be a runtime check. And also it means that it could fail because it could be, if let's say you give it two overlapping ranges, you say, I want to get, 1 through 4 and also 3 through 7. Then those two ranges overlap. And so therefore the value you get back is going to be an error instead of an okay. So these methods have a result return type where you actually need to check for the case where they ended up being overlapping. And therefore you couldn't get, mutable pointers to everything you asked for. I also think you didn't really, so we had, split mute at for slices for a long time.
Mm-hmm.
But we didn't really have the equivalent for hash maps. Whereas this one, so like crucially adds the ability to do multi lookups into hash maps. Or multi, mutable pointer lookups into hash maps. You could obviously do it with you could do shared lookups in hash maps by just getting the keys separately. But the mutable part of that, we didn't really have an API for before. This next one, I think is pretty cool. So there's something called the target feature attribute. The target feature attribute has existed before 186, and it basically tells the Rust compiler you can put it on a function, and it tells it that for the body of this function, make use of the following CPU feature or CPU feature set. So things like SSE or AVX2 or AVX512, like things that give you, for example, SIMD operations or other kind of accelerated instructions. Now, previously, only unsafe functions could be marked with this attribute, because, and the thinking here goes, well, what if the CPU you're running this program on does not support that feature set? well, then the program is going to run invalid assembly instructions and everything gets sad. And so we're going to require that the functions are unsafe so the caller knows to make sure that they've checked that the CPU supports those features before calling that function, and maybe calling a fallback function of some kind instead. Now you're able to write or put the target feature attribute on safe functions. And the rule now is those can be called safely from other functions that have the same target feature attribute. So if you have two functions that both have this target feature required, one can call the other without needing any unsafe. You still need unsafe somewhere higher up, to call sort of the first one in the chain. But this is also an interesting thing that I haven't really seen elsewhere before, where putting the target feature attribute on a function now makes it kind of conditionally unsafe. So it's safe to call from other functions that have the attribute, but it's unsafe to call from anywhere else.
Mm-hmm.
But it does kind of match the behavior you want with this, right? Which is you want the ability to call this function from somewhere that doesn't have it because you need to call it from main somewhere. Like you need to be able to enter the call chain.
My unsafe FN main, you mean?
Right, exactly. But eventually you like once you're in the world where this target feature is enabled, you just kind of want to not have to restate that unsafe or that safety guarantee again.
So next up we have debug assertions that pointers are non-null when required for soundness. And we mean pointers here, not references by default, or by construction, references are non-null in Rust, but pointers, raw pointers, C-style pointers, can be null. And obviously to use them safely, you should first, if you're getting them from some unknown source, check that they are in fact non-null before you try to dereference them and either do a write or a read or a cast to anything else. And so this,
or you can live on the edge and just don't.
Just live on the edge, just YOLO.
Or you can write Java.
Unsafe FN main. Yeah. The, least safe thing of all. And so, in this case, this is a new feature where the compiler only in debug mode. So kind of like how, for example, integer overflow is checked in debug mode and just wraps in release mode by default, and you can configure it. This new feature says, hey, anytime you do a read or a write or, reborrow any sort of, pointer into a reference, which again, references must be non-null, it will insert a debug assertion check. And so I think I look this a lot actually. I'm not really sure. I was asking if it's, possible to turn this on even in release mode.
Yeah, I don't know. I mean, for bounce check, you can turn it on even though you're compiling in release mode. So I feel like even if there isn't a config flag, one might be added.
Mm-hmm.
But yeah, I don't know whether it currently exists.
Mm-hmm. But yeah, very great for hardening. I mean, if you're doing high assurance stuff, you definitely want to turn on the, checked overflow stuff. And I can imagine, like, in some cases, you could probably turn it on and off and measure. And if it's within the appropriate bounds in terms of runtime performance, just leave it on at all times.
Yeah. They do make it very clear, though, that because this is just a sort of, it's just intended to be a footgun check kind of thing, you should not rely on this for soundness. Well, even if you had an ability to turn it on in release mode, you should not be like, oh, I have this on, so therefore my code is fine now.
Mm-hmm. You'd still need to have an unsafe keyword to actually do the read and write still. So it wouldn't change the fact that you would, have an unsafe contract. Similarly, like the reason that, overflow isn't unsafe is because to actually turn it into memory unsafe, you must be using that overflowed thing somewhere else that is itself using the unsafe keyword. And so I think turning it on release mode, they're saying here that because it's a debug assertion, you can't just like assume it's true.
But I think it's one step further than that, right? Which is they don't want to guarantee that this check happens everywhere.
Mm-hmm.
Like that they haven't missed somewhere.
Sure.
So the worry, right, is someone turns this on in release mode and then in their code, when they have that unsafety contract, they go, //safety : and they write, the program would have panicked because of the null checks injected by the compiler. And because it hasn't, then this operation is safe.
Mm-hmm.
And they're like, don't do that.
Sure. But I see a parallel there in terms of like, the overflow checks. Cause you could, the same way that you don't check for overflow, you could just say, hey, like we got here. And because we know that we in our code have turned on overflow checks that we don't need to check manually. And so you could argue it makes it easier to, if that code gets copied and pasted out somewhere else that doesn't have that check turned on, it could be a problem. So I don't know. I think, I would be fine relying on it in release mode. They're just saying here that it's not implemented and that it will only panic in debug mode, so you can't use it as for soundness. But mileage may vary.
This next one is one we've touched on in the past when we talked about the introduction of C unwind. But the extern keyword in Rust is it has a sort of built-in default value of if you write extern without specifying the ABI to use, then it will assume that you meant extern C. And for a while now, it's been recommended that you explicitly say what ABI you want to use, even if you're using the C ABI. And I think part of the reason is because they want to encourage people to think through that choice. So for example, even if you want the C ABI, do you maybe actually want C unwind? And in 186, the lint that tells you, oh, you haven't specified an ABI for this extern has now become worn by default. It used to be allowed by default, so you could turn it on, but it was just hidden. But now it will actually warn you. I don't know if they're planning to make this a hard error. I assume not. But at least now it's surfaced to you.
So there was a target deprecation warning for the i586 PC Windows MSPC. I've never heard of 586 before. I've heard of 486 and
I think
686.
I think we talked about this maybe on a past episode where the i586 is like the Intel Pentium processor.
Is that the x87 I hear about, or is that something different?
No, that was that Itanium or something? No, that was different. No, but I seem to remember I feel like I've read this exact Wikipedia article before. And I think the 586. Oh, here we go. I think the 586 is just it's the Pentium. It's the first Pentium processor. And so it's just very old. And presumably then there's a lot of compiler features it doesn't support. It's not just about the clock speed, right? It's the various CPU features that you can assume that a processor is going to have. I think also i586, there's no 64-bit. There's only ever 32-bit. But it doesn't seem likely to me that we have lots of i586 Windows users anymore.
Mm-hmm. Under stabilized APIs, I liked, there's two new ones on floats, next down and next up.
Yeah,
so if you've ever wanted to go to, it's not like going from 1 to 2, it's going for obviously.
Epsilon higher.
Among the non-nan and non-infinity parts of floats, there is an ordered subset. And so for every integer, for every float, there is a next float in the list. And so you can get some minuscule larger float.
Yeah, and the thing I think is particularly interesting here is people think that you can just take any float and add epsilon. Epsilon is actually a constant on the float types that is the smallest representable unit. And so you could just take your number and add or subtract epsilon, and now, you have a next higher or lower number. But the reality is that the way IEEE floating point numbers work, the epsilon is not constant across the whole space. So depending on the value you have, the difference to the next representable number, the next number up or down that has a bit pattern you can write down that is a valid IEEE, varies. So there will be some floating point numbers where if you add epsilon, you get the same number because plus epsilon is not representable. So it just reverts to what it was. Whereas next down and next up will actually find the next bit pattern that's representable, that's the smallest delta from where you are.
And so the epsilon constant is just the smallest epsilon possible?
Yes. As far as I know, the epsilon constant is the smallest epsilon you can represent in F64.
That you can represent.
It's the smallest difference between two F64s.
Okay.
But that doesn't mean that epsilon is valid for your F64.
Yeah. It's kind of so in Minecraft, there's the idea of as you get farther away from spawn, because spawn is 0, 0, on the coordinate system, as you get farther and farther away, you start like taking like everything gets like jerky and starts jumping. You're like snapping from one sort of like coordinate to the next, and it gets like farther and farther apart. Yeah. Actually, you can't move at all because like the distance you would move in one game tick is no longer larger than the
representable. This is also why you should not use F-32s for money. Like, if you've ever thought about using F-32s for money, please stop. Like, money should be ideally fixed decimal or fixed point rather than floating point. I also thought, vec pop if was kind of interesting.
Yes.
So pop if is a method so there's vec pop, which removes the last element of a vector, and pop if is essentially syntactic sugar for if some condition is true for the last element of the vector, then pop. Otherwise, return none. And you want this because it can actually be kind of annoying to write that code otherwise, because you need to write, I'm going to try to live write this now. I think you have to write, if let sum last end bracket equals vector dot last open curlies. And then if, or you could chain these now that we have let chaining, but
not in this version though.
Didn't that come earlier?
I think it's in.
Oh, it might be later. Okay. So in this version, even better. Mm-hmm. Then new line, then if, and then the condition you want evaluating on last. And if that's true, then open curlies, and then, vector.pop. But if you wanted to capture the value of the vector.pop, you need to have let mute popped equals none above the outer if, and then you set that equal to the result of doing pop inside the inner one. Mm-hmm. So it's like a solid 6 lines of code to do what pop if lets you do with 1 line.
Mm-hmm.
So pretty neat.
Good little helper. In terms of const stabilized functions, I like that black box is now const stable, a function which deliberately does nothing except tell the optimizer don't optimize this. It has literally no runtime behavior.
Yeah, I love that a lot. I also did my dig through the detailed release notes. I found a decent number of ones actually in this one. One of them was, so when you invoke rustc directly, which you don't have to go through cargo, you can pass the -O flag, $O, to enable optimizations. And it matches what you do in C land, for example. If you run Clang or GCC, you'll often pass -O to get an optimized binary. It's sort of roughly equivalent to release mode. But in Rust, -O is opt level 2, not opt level 3. Opt level 3 is like the highest level of optimizations, and opt level 0 is no optimizations. And for whatever reason, $O in Rust used to just turn on opt level 2, not turn on all the optimizations. And in 186, -O will now finally do opt level 3. And so you'll get very slightly faster binaries if you were invoking rustc directly and you were passing -O. So good for those 2 people in the world.
The last thing that I saw in the detailed release notes was the compile time improvements on AR64 Linux, which went from maybe about like 25% faster in some cases. And so
this is they enabled optimized AR64 builds using the optdist pipeline, which I don't think I know anything about. But they still have...
So for the compiler itself.
For the compiler itself.
Now ship binaries that are optimized better.
Yes.
So.
There are still some optimizations that are only turned on for x86-64, like Bolt, which gives you... it like lays out the binary differently to get faster execution speeds. I think maybe what they did turn on here, and someone's going to have to arrest me on this, but I think maybe what they turned on was like PGO style optimization, where you run the compiler a bunch, you gather metrics, and you use that in the second compiler optimization pass to basically tell the compiler which paths are cold and which are warm, so that it better optimizes the warm paths. Mm-hmm. But don't quote me on that, but they have now optimized that build more somehow. I found a few other smaller things. So one of them is, cargo used to have like when you want to authenticate a cargo operation that talks to crates.io, normally you're supposed to use cargo login and stores your crates.io token in a file in your file system. But Cargo also has a -- token flag that lets you pass it on the command line. That flag is now deprecated and hidden from all commands because you don't really want to put secrets in arguments in command line invocations. And the primary reason because they go in your shell history. And so now those tokens are just like in your shell history forever, and you probably forget that they're there. So they've been removed from there. Cargo also removed the use of "did you mean" in error messages. So error messages and warnings from Cargo will no longer say "did you mean." Instead, like, they won't ask you that as a question. They will instead just say what they found. Mm-hmm. And apparently this is like based on some user research and also based on the rustc diagnostic guide, which says do not ask users questions because they cannot answer you. Like, instead, just tell them the information. Uh-huh. And the last bit is you can now enable you can now switch to sans serif fonts for text in Rustdoc, which previously was not possible.
Well, I mean, Rustdoc, Untitled.rs allows you to inject arbitrary code into your own render documentation, and so you can do pretty much anything.
That's true, but now there's a checkbox in settings.
Mm-hmm. We should definitely link to ponies. You're aware of ponies?
Oh, yeah.
In the release notes, the show notes. PWNIES. It's a crate. So look it up.
It's disturbing. I think that brings us to 187, and 187 was a big release because not in the sense of it had lots of contents, but in the sense of
important release.
Yeah, it's an important release. Not
symbolically.
It's not as important as the 169 release, of course.
Yeah.
But it is important in that it was the 10-year anniversary of Rust.
10 years to the day.
Yeah, it's pretty wild. I guess the math works out such that this whole like release cadence of Rust is something magical about it.
They're always thinking ahead, these Rust developers.
It's like we exactly got 10-year anniversary and we got 169 on 420. Like there's some clever people behind the scenes here for sure. In 187, we got anonymous pipes. So this is for IO pipes. And the thinking is, imagine that you want to run two commands, like process commands.
Yeah. Stood process command.
Right, exactly. And you want to take the output of one and pass it to the input of the other. So similar to literally the pipe character in your shell. Previously, that would actually be a little bit annoying. So you could create, like many operating systems have this notion of a pipe file where you can create one and then you give a write handle to it for one and a read handle to the other. But you would have to like interact with the operating system, and like different operating systems have different ways of making them. There'd be crates that implemented this. Or of course you could write to a vector and then have a background thread that read out of the vector from one and wrote into the vector the input of the other, but that is like annoying and you need to carry a thread around. And so now in 187, we have this notion of anonymous pipes as an abstraction in std.io, where you can call std.io pipe and it gives you back a read handle and a write handle, and you give the write handle as the stood out to one command, and you give the read handle as stood into the other command, and then the data just kind of flows. And I'm assuming that behind the scenes here, this is uses whatever mechanism each operating system provides for giving you pipes. But it does mean that it is a lot easier now to tie commands together in that way.
Now we have safe architecture intrinsics. And so by intrinsics, we mean the functions located inside of the stood arch module, where if you've looked in there, there's literally thousands, like over 10,000, maybe even over 9,000.
Are there over 9,000?
Yeah, there are like 10,000. I think that's a bigger number, unless you wrap around, so it could overflow. But yeah, and so, previously, I believe all of these were unsafe. And now, well, I guess they were unsafe probably for the reason we talked about in the previous release, where target feature was all implied, could only be used on unsafe functions.
So all the functions had to be unsafe.
Yes, so kind of like by this restriction. And so now that's been lifted in the previous release, in this release, now they have gone through and said, hey, this can actually be safe. You don't actually need to, but you would still be required to at some point use unsafe code to actually enter this kind of like a target feature context, if you will, where now that we know that we have sort of established we are in this target feature, or this target feature is what we're currently operating under on the CPU that we're on right now, we can now just call functions that need to use the unsafe keyword. So
yeah, and I'll give a sort of I'll hoist the thing from the detailed release notes to here, which is I found a PR 138162 for the people following at home, which is a PR that updates the Rust standard library to use the 2024 edition, which is where we got that ability to use target feature on safe functions. And it was interesting to me that they basically went through and updated a bunch of things on the standard library to use the new edition. And I'm assuming that's one of the reasons we got this, exactly as you say, because now they could make those functions be safe, because the only reason they were unsafe were the target feature required it, which is no longer the case. This next one, I think is a little, it's a little funny. So when you have the assembly macros, you write inline assembly, you usually do that because you want some kind of lower level control over exactly the machine instructions get executed in the exact order they get executed in. And now you have gained the ability to write Rust code that runs in the middle of the assembly you've written. So
inline Rust code.
Yeah, it's inline Rust code as opposed to inline assembly, but it's inline Rust code in the inline assembly in the inline Rust code.
And can we use ASM from within this?
I'm sure you can.
Oh, wow. How deep can we go?
Yeah, I know. You can only go one level deep.
Oh, okay.
That's a rule. No. It's not actually a rule. It just feels like they should just put an arbitrary limit on this just so people don't go insane.
There's got to be a compiler test somewhere to say just try like nesting it over and over and over again. And if not, great first contribution.
Surely they've thought about this. The clever Rust compiler people, and it just works for arbitrary nesting.
But very fun. You can now embed Rust code inside your inline assembly, inside your Rust code.
Yeah. But the syntax for this is basically you write an assembly, or not even the syntax, but also like the representation they have is as an argument to the assembly macro, you can now give the label keyword and then open bracket and then write Rust code. And that argument will become a unique label in the assembly. Basically, it's compiled into assembly code and it gets an assembly label. And then in the assembly code itself, you can use, curly brackets to refer to various of the other arguments to the assembly macro. The curly bracket that refers to that label will then be an assembly label that you can use as an argument to things like the jump instruction, for example. And so that would then have the assembly jump to the compiled assembly for the Rust code that was in the label that was mapped to the curly bracket that was at that jump.
Mm-hmm. So we have next here, precise capturing in impl in trait definitions. And so think back to 1.82. We added this new weird looking syntax. I think it's looked pretty weird. This use keyword, use angle bracket, and then you have the idea being that if you're capturing lifetimes in certain cases, you want to be explicit about what you're capturing. And so this should be pretty rare. I've never seen it in code myself. I'm not sure if you have used this feature yet.
Yeah, it comes up in asynchronous code.
Yeah, async.
Not very often, but often enough that I've used it.
And what this new feature, that was in the 82 release, and this new feature is that this now also works in impl. So if you have a type declared as impl, you can now use this kind of, so you could say impl foo plus, like you would normally bound a trait with the plus use something.
I think it's actually even more specific. It's in impl in trait definitions.
Oh, okay.
So you can already use it with impl in 182, but now you can use it with impl in trait.
So this is about, this is about, again, async stuff, needing to return traits upon traits.
Yeah, and I mean, I think that's exactly it, right? Like you have a trait where you have functions that are themselves, like for example, return impl future, and now you want to be able to use there, and now you're able to. Where previously you couldn't use in traits. And therefore with impl future, or other impl traits. So this is like, just expanding the natural places in which people might want to use. I think that brings us to stabilized APIs. One that I spotted here was vec extract if, which is very similar to the pop if we just talked about. Except that extract if gives you an iterator of all of the things that you removed. You can kind of think of extract if as being similar to retain. So vec also has a retain method where you give a closure where only the elements that the closure returns true for are left in the vector, everything else is removed. Extractive is sort of the same, except instead of dropping them, it returns them to you in an iterator. One useful note about extract if, though, is that if you stop consuming the iterator partway through, only the items that it walked through and returned to you are extracted. The remaining ones are left in the vector, even if they would have matched the closure. I remember like part of the debate for this one, and one of the reasons why we haven't had extract if before is because they were trying to agree both on the naming and its relation to retain, and whether it should be extract if or retain if. But I guess it landed on extract if, and now there's also a bunch of code you don't need to write yourself, and you can use this handy implementation instead.
So there's also this these split off methods on slices too. How do those differ from split, mute, etc.?
So split off, I think, only splits at the end.
Well, it says it takes a range, but the range must be one-sided.
Yeah, exactly.
Which, like, it seems like the same as, like, just giving an index, and then I guess it could be from either the front or the back, and so...
But that's already the case for split, but I think the thinking here is, with split, you give an index, and it gives you the return type is a two-tuple with the slice before and the slice after the index. This one is you tell it the range you want to pull out, and then the rest is left in self. And so that being the big difference, that in split mute, self is left as being the entire range, whereas with this one, the self itself is modified. And I think the other difference is because you give the range you want, like if you do split at, then you would need to know whether to pull out the first or the second argument of the tuple, depending on whether you wanted the range until or the range after. Whereas here you can just give a range and the range is what you get back. So it's slightly more ergonomic, I think, for that use. I also thought it was interesting that we got a display method for OS string and OS stir. We already have something similar for path. So if you have a stood path or a path buff, they don't implement the display trait directly. So you can't just like print them or format them. You have to call .display on the path, and then you can print the resulting type. That resulting type implements the display trait. The reasoning being that for paths, the display representation is not, it's not lossless. Especially, I think this is true on Windows, where they have some like weird characters in there for certain types of paths. And so when you display them, you can't then immediately take the output and turn it back into a valid path. And so they want to make it explicit that you have to call display and you get something that's displayable, but it's not the original thing. And OS stir and OS string are similar in that OS stirs are the way that your operating system represents strings, which on Linux is usually UTF-8, and on Windows is UTF-16. And here too, if you display them, they might not turn back into the exact same. Like it might not be a lossless conversion into a string representation. And so they want to signify that. And previously, it was kind of annoying to display an OS stir because you had to call .toStir or asstir, which gives you an option stir that you can then print. But if it couldn't be turned into a stir, you had to like just print out the bytes. And so now I guess you have a sort of standardized way to visualize it.
I saw some interesting, further stabilized methods on integer types. And so we have cast signed and cast unsigned, where the idea being that if you have, say, a U8 and you want to turn it into an I8, previously the best way would be to either use the .into trait or use it as cast. And so if you just want to have a sort of more constrained version of that, that's also documenting of what you're doing here, just changing the sidedness. There's now this cast signed or cast unsigned to go from signed to unsigned and back.
I don't even know if you could use into previously. So you can do into, like, U8 implements into U16, but U16, I don't think implements into I16. Because you can't.
It would be a try into.
It would have to be a try into, yeah.
So, and it should be a trivially possible sort of thing, right? And so if you know that you want to cast away the soundness, it's not actually changing. It's a total runtime no-op. It's just doing a reinterpretation of the bits. And so it's also is multiple of.
I've used this a couple of times already, actually.
Just talk about how it's equivalent to foo mod bar equal to 0, right? But what if bar, the right-hand side, is 0, right? Normally it'd be divided by 0. You would get a panic. And this just says, hey, like, we know what you want to do here. Like, if it's multiple of this, then yes, so it's fine. A 0 dot is multiple of 0 is true, and n is multiple of 0 is false.
It also means that you have code that I think just reads easier. Like, the number of bugs that come from people forgetting whether it should be modulo n equals 0, modulo n not equal to 0. Like, I'm sure that bug has happened a gazillion times. And now the code just says is multiple of. And it returns a bool.
Reads much better. Also, the unbounded shift left and shift right methods on ints now, whereas previously, if you were to shift an int via by an amount greater than its length, you would get a panic. This just says, hey, if you shift by an amount greater, you get 0. It's kind of like you shift everything off the end, and it's kind of equivalent to how, like in Rust, again, we have the ability to configure what happens on arithmetic overflow, where if I add a number that's too large, by default, it will panic in debug mode and then wrap in release mode. But there are ways of saying, hey, always panic or always wrap. This is like saying, hey, I am deliberately opting in to passing in a possibly over large shift. And if that happens, I just want 0. And so a way of being explicit about your intent.
Yep. I saw two other things that were kind of interesting that was stabilized. One of them is just try from vec-u8 for string, which I think we already have this, right? Which is string from UTF-8. So there's a helper function that lets you create a string by passing in a vec-u8, and it, tries to parse it as UTF-8. Now that is also represented in the try from trait implementation. The other is that now if you have a box, maybe uninit of t, you can now call write, so box : write, and give it that box maybe uninit and a value of type t, and it does the cast for you into box. Previously, you could also do this, but it would require unsafe code. Whereas now the sort of wrapper is safe in that if you have a box maybe uninit and you have a t, well then you now have a box t, right? Because you overwrite the maybe uninit t with the t, and now you know it's initialized because you just wrote to it. And the standard library now has a function that represents that knowledge. The only thing to be aware of is that it will not drop the previous value because it doesn't know whether it's initialized. And so if you wanted to drop the previous value, you would still need to use unsafe here. And then in the detailed release notes here, there's not too many. One of the ones we mentioned, the home dir function in the 185 release, and it was undeprecated in 185, but it was only undeprecated in the documentation of the function. It was not, they didn't actually remove the deprecated attribute on the function, which is purely just an oversight. And so in 187, that function is actually undeprecated, not just documented undeprecated.
One more API that we forgot to mention was the string extend from within. So do you want to talk about this?
Yeah, so this is that, when I first saw this, I was like, who uses this? So string extend from within is you have a string, you give a slice, so
a range
that you want to slice the string, that you want to slice out of the string, but not slice out in the sense of remove, but in the sense of take the slice that is that range in the string, copy it, and append it to the end of the string, which is like a weird, like, I couldn't immediately think of why would you want to use this. But then I think in the Reddit thread, about the 187 release, someone linked to a GitHub comment where someone described a use case that they had for this. And apparently the use case was they were generating a textual representation of a graph. And then that graph could have, it was not a tree. It could have cycles-ish. So you could end up visiting the same node through multiple paths. And when you want to print that node for the second time, you can really just print the same representation you used the first time. And so if you keep track of where in the string output the output for every node is, then when you discover that you hit that node again, you just take the index you've cached, read it out of the string, and append it to the end. And so that's exactly what this function does. And you could do this without a helper function, right? You could just slice,
you would need to either copy or use unsafe code because you would have had to have both a mutable reference and then for the slice, a different reference.
Right, exactly. So you could do this before, but it was like, it required either keeping a separate copy or unsafe, and now it doesn't.
Also, I think an argument too is that this already exists for vec, and string is to some degree just a vec. Obviously not just, but it is largely similar to a vec.
And then there are two features in Cargo that landed in 187 that I thought were pretty cool. One of them is implementation of RFC 3553, which adds the ability for Cargo to generate SBOM files. So SBOMs are software bill of material files. So they basically list every version of every dependency that went into building a given binary. And so now in your cargo config.toml under the build table, you can write SBOM equals true and Cargo will produce an SBOM. I think this is it's fully implemented, but it still requires a -z flag, like an unstable flag to Cargo, to generate this file because I don't know if they've fully stabilized on what the contents of the SBOM are going to be. Like the output is not necessarily stable. But I do think it's very exciting that we're now getting progress on the ability to do this sort of very, it's like one of the cornerstones of supply chain security that is just directly supported by Cargo. And then the other thing is in 187, Cargo added better terminal integration with certain ANSI escape sequences. In particular, there are some ANSI escape sequences that on Windows are used for terminal programs to indicate progress bars in such a way that the Windows UI knows that terminal window is doing something that's progress. And so you can, now when Cargo does a Cargo build, for example, you should see in your little, task manager bar at the bottom of Windows, you should see, a little green progress bar move across the icon for your terminal when Cargo does something. And it's it doesn't matter, but it's also cool that it's integrated now.
All right. And that's it for 87.
Yeah. I think so now we've been through 10 years of Rust.
Yeah.
Ish. Let's ignore the fact that we didn't do the first 35 releases, but we'll do those one day. When we have the time.
It's, today is our, the 6 7/5 anniversary of Rustacean Station.
Hooray! Celebrate with us. I'm just imagining a bunch of people sitting there listening whoa, really? That's so cool.
Every day can be an anniversary if you just use floating point numbers.
It's true. It's true. Cool. Well, we will see you all very shortly because
imminently. This headlock is getting very uncomfortable, and so we need to stretch our legs a little bit, and then you can come back in here and put me in different sort of submission hold.
Yeah, I basically just now need to hold Ben in a headlock for 19 weeks, which to him will feel like only mere minutes have passed until
time flies when you're having fun.
Yes, exactly right. Cool. Well, we will see you all on the other side.
Farewell.